Okay. Given a string S, return the number of unique palindromes. Unique palindromes in length 3 that are subsequence of S. Oh, wait. Low key, this is easy. This is a sliding window. Oh, subsequence? No, bro. No, bro. Oh my gosh. Okay. First thing I'm thinking of. Usually these subsequences is backtracking. Actually, no. I take that back. I don't know if that's true. I don't know if that's the case. But we have to generate every, like, there's no way out of getting, how do I explain this? We have to generate every permutation because we have to determine if any of those permutations are subsequences. And because we have to generate permutations, that's why I think it's backtracking. And then when we reach a string length of 3, then we'll check if it's a palindrome and then add it to an output array, if that's the case. So, or actually, a counter, I guess. Integers primitive type. So honestly, it might be easier to do this. So we're making an output array. We backtrack with S, 0, S. This is the current index, S, new string builder, output, and then we return output.size. And then we make public void backtrack int index string S, string builder with string output. So if string builder dot length equals 3, and is palindrome, to string. String, yeah, something like that. Otherwise, for int I equals 0, I has to be less than s dot length plus string builder dot append I s dot char at I, and then backtrack index. To be honest, we don't need index. S string builder output. String builder dot delete char at string builder dot length -1. Yeah, something like that. We can probably cache with a hash map too. I might do that. So APA. Might have to be that. Yeah. And then we make public is public boolean is palindrome string s left equals 0 and right equals s dot length minus 1 while left is less than right. Yeah. S dot char at left does not equal s dot char at right. Turn false. Left plus plus right minus minus. Turn true. See if this works. Nope. It's definitely my backtracking. I don't. Okay. I'm gonna change this up. We're gonna add index back. Index s string builder output, and then here it's index plus 1. Yeah, and then here we go string builder dot deletes char at s dot char at or string builder dot length minus 1, and then we backtrack index plus 1 s string builder output. Try that. Same thing. Wow. Same exact cases. What about this? Palindromes. Hash set. Set string palindromes. Palindromes. gems does not contain. Maybe I'm just adding duplicates. I don't even need to add that check really. The hash set will take care of that by itself. Let's just keep it there for now. What? Oh. Oh my gosh. Okay. This definitely isn't efficient. I can tell you that. Don't time limit me. Don't time limit. Oh, I'm getting it. Yep. So that means I was duplicating. But we want duplicate values, don't we? Unique. Okay, no we don't. How else would you do this? Could you do a 2-pointer with the closing window? That would be faster than this, for sure. Okay, so if this doesn't work, we might be able to do something like this. So we loop through the entire string. Jeez. Okay, we loop through the entire string. left, right, center. Doesn't really matter what the center is. We should do hash set just in case for now. No, this won't work. This will not work. Maybe this is some prefix thing. Something with a prefix sum, I guess. 1, 2. But per letter? Because then you would have to have something like prefix sum equals something like this, and then 26. And then to be able to calculate it, you would have to go int I so that's how we would track but you'd have to be able to track on the left too. Alright, I'm looking. But how do we know that it's sandwiched? What the heck? Come on, LeetCode. It's a weekday. Sets and maps of anything. Oh, wait. Why are they constant? Wait, yeah, but is he talking about how is it constant space? I was gonna say this guy's tripping. Which one looks more intuitive? This is better time complexity. So let's do, or space complexity. First equals new int 26 and new int 26. Has to be less than its total length. Plus. Bruh. Interesting. We get the first index and the last occurrence of it. Okay, okay. So that's what this is doing. We're getting the first and last occurrences of each letter. Okay. That makes sense. Oh. Are we gonna count? Less than or equal to, I'm not even looking last I. Yeah. Between dot add s dot char at j, and then output plus equals between dot size. Yep, of course. Oh, I know. +1. Oh, because we don't want to include that, and we also don't want to include this. Makes sense. Yeah, that makes sense. That's tricky. Can't believe they didn't accept. They should accept the backtracking. Like, why can't you just make it right here? The backtracking was smart. I guarantee you, if you told people to write this with the backtracking method, it would be a lower acceptance rate. Almost guarantee. I don't know if I can fully guarantee. Let's try to refactor that to be better. Actually, honestly, first is pretty good. Int last. Int 26 erased. Let me explain. So we're going to make an array that stores the indexes of each letter and their first occurrence. And then we will have an array that stores each of their letters and their last occurrence. And then we're going to fill the first array with -1. Then we will iterate through the entire word, each character of the word, sorry. And we will calculate their index within each of the arrays by taking the current character and subtracting it by a. If the index of, sorry, if the letter at has not been encountered yet, we are going to set it, and then the last index, we'll set it to wherever the most recently visited character was. And then we have output equals 0, and then we iterate through all the letters. So if we don't encounter the first letter at all, we're going to continue. And we are going to... that makes sense. Okay. I was going to ask how can we guarantee last is there, but first and last can be the same. So for int j equals first I plus 1, j has to be less than last I, j plus plus. We're going to make a hash set with a character set equals new hash set. And then set dot add s.char at j. Yes. And then output plus equals set.size. Return output. There you go. Time complexity is O of n, space complexity is O of 1. Only because these are constants. Wait. How is this a constant space? It should be... We're making a set for... we're making 26 sets, so that's constant space. But then... Theoretically, as the... I don't know if I agree with that. How is space complexity 1 here? If we use a set here... Don't we add n characters to the set though? Is set character space always constant? Oh. Oh my, that's so dumb. That is dumb. Damn. Okay. Let's do a random question. This is a NeetCode question, isn't it? Can't you just... Wait. This is not... This is the wrong text editor. It's giving me the palindrome text editor, but for this problem. What? Okay, there we go. Jeez. Can't you just do this? I hope this problem doesn't give me a hard time, because I gotta go somewhere. Have I submitted something for this? No, I haven't. That's the problem. It has to be separate. I don't know. And I'm not going to do it because I got to go. Dang, only one problem today. That is not hot. That is not hot. 200 days badge? What does that even mean? What is the 200 days badge code for? Consecutive days? Oh. However many active days. Yeah, I better with this kind of heat map, bro. All of this and I've accomplished what? Nothing. All this and I've only gotten one full month badge. What even happened during these days? September 9th? What happened September 9th? What happened September 23rd? Like, I know what happened here. I was just on vacation. But what happened here? I don't know.